Okay, start 2. So we have x, let's put it x, modulus 2x add 1, take away 1 equals 0. And remember to solve them, it's best to draw a graph. However, I don't really want to draw a graph of x times the modulus. So I'm going to rearrange it by taking the 1 to that side and then dividing both sides by x to get that. Because I know what the sketch of that looks like and I know what the sketch of that looks like. So I'm just going to put them on my graph so I can show you. So we have, if I delete that, then it's options, numeric, abs, 2x and 1 and 1 over x. And then I want to change the V window. If I just click initial, no, that's like trig there, initial, it'll take me back just to a nice square one. So I have that, and then I have my V for the modulus like that, and that's going to go up there. So there's only one intersection we have. So I'm going to use the graph just to see what the answer is. So we're going to G-solve and intersect. But I know that x is going to be a half, so that's what I'm aiming for. Now if you look here, this line is the positive line. So that's just 2x at 1 and 1, so it's a positive gradient. So I'm just going to solve 2x at 1 equals 1 over x. Because this branch, the negative branch with a negative gradient, doesn't intersect at all. So I don't need to worry about putting the minus difference at all. So times both sides by x, so 2x squared at x equals 1, take away 1, and then solve it. So 2, 1, minus 1, we get x is a half, and x equals minus 1. And the reason we cross out minus 1 is because if you imagine this line carrying on going down, it will be here where minus 1 is. Okay, next one. Find the equation tangent to the curve y equals 5 cos 2x, where x equals pi over 6. So straight away, make sure you're in radians. And what we're going to do is we need to differentiate it. So, well, actually, first we'll just sub in x equals pi over 6. So 5 cos 2 times pi over 6 gives me y equals 5 over 2. Differentiate it. So cos goes to minus sign. And you times by the derivatives, times by 2. So it gives me minus 10 sine 2x. Sub in pi over 6 into that. So minus 10. And we get m equals minus 5 over 5 root 3. I don't need to do negative reciprocal, it's just the tangent. So I use y minus y1 equals m x minus x1, which was pi over 6. Okay, so to get rid of that 6 in the bottom, I'm going to times both sides by 6. So on this side, I will get 6y, take away, when I times this fraction by 6, the 6 and the 2 will make 3. 3 times 5 is 15. When I times this by 6, I can straight away take them inside the bracket. So I get 6x. And when I times 6 into 6, they cancel out, so I just get minus pi. Then expand it. So minus 30 root 3x plus 5 root 3 pi. Take everything to one side. So 30 root 3x plus 6y. Take away 15, take away 5 root 3 pi equals 0. Or rearrange that to get y equals 0 if you want to. Now, just to remind you, you can draw a sketch of that. So if I do 5 cos 2x, I only change the V window to trig. And if I zoom out a little bit, and then if I go on to sketch, tangent, and I want pi pi over 6. Pi over 6. There we go, it gives me what y is, 2.5. And it gives me the gradient is there, minus 8.66. So I can just check that. Minus 5 root 3 minus 8.66. There we go. So it looks like I've got it right. Okay, next one. Binomial expansion up to x cubed of 1 over root 4 plus x. Well, straight away I can write as 4 plus x to the minus a half. I can take out the 4 because I need a 1 at the front. So I get 4 to the minus a half, 1 plus quarter x to the minus a half. Okay, so 4 to the minus a half, that gives me just a half. And then I'm going to do binomial on this bracket here. So it's 1 plus n x plus n minus 1 over 2 times 1 times x squared plus n minus 1 n minus 2 over 3 times 2 times 1 x cubed. So then I'm going to simplify this. So it's 1 minus 1 over 8x. Let's see how much of this I can do in my head. That's going to give me 16, 32, 64, 128 on the bottom. And on the top, I'm going to get plus 3 x squared. This one, oh, that 3 and 3 will cancel. So I get 64, 128, 256, 1 or 24 on the bottom. Still got that 5 to go on the top. And I've got minus, 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 so I've got a minus there, x cubed. Or you can just type it in your calculator, then expand that, and we get half, take away 1 over 16x, plus 3 over 256x squared, take away 5 over 2 or 48 x cubed. So trapezium rule, 5 strips to go from 0 to 1. So straight away work out h. 1 take away 0 over 5. It's 0.2. So I'm going to go up in 0.2s. So 0, 0.2, 0.4, 0.6, 0.8, and 1. You can use the table, remember. So e to the minus x squared. And set the table starting 0, 0.1, 0.2. And it says do 4 decimal places and they're working out. So 1, 0.9648, 0.8521, 0.6977, 0.5273, and 0.3679, that would be. Okay, then trapezium rule says half times h times first at last and 2 times the middle. And then close both brackets, type all that in your calculator, and we should hopefully get 0.394. And last one. So we have a small ball projected upwards. So it's going to go up and come back down. Here's the point A, which is 40. Oh, sorry. finish up with the question. So that highest point is 40 meters above air. So I need to pick a direction. Well, up makes sense to be positive. So if I do that, let's write down what information we've got. Well, if I pick this point here to be my final point, the top point, I know that V is 0. I know that S was 40. I don't know U. I know that A is minus gravity, so minus 9.8. And I don't know the time. So I can use the Suvat formula of T. So V squared is U squared plus 2AS. So 0 is U squared minus 2, only go back into there, 2 times 9.8 times 40 minus 784. So U squared is 784. So U is square root again. So U is 28 meters per second. And we also want the time it takes to return to air, so the time to get back to here. So if we do that again, we know that S is 0 this time. We know that U is 28. V, we don't know, but in fact it will just be minus 28. A would be minus 9.8, and T is what we're trying to find. So we need the formula about V. So that's S equals UT plus half AT squared. So 0 equals 28T minus a half times that's 4.9 T squared. So what we get is we either get factorize out T, we get T is 0, or we can solve this and get 4.9T is 28. So T is 28 divided by 4.9, 5.7 seconds to two significant figures.